In part A of this trigonometry subtopic, degrees, minutes and seconds, we covered a brief history outlining how we came to measure angles in degrees and how we can represent fractional parts of 1 degree. Let's revise the main points that you will need to know. 1 degree is 1/360th of a full revolution. In other words, 360 degrees equal 1 full revolution. 1 degree can be split into 60 smaller parts called minutes, so 1 minute is 1/60th of a degree. Similarly, 1 minute can again be split into 60 smaller parts called seconds. So 1 second is 1/60th of a minute. Notice that these subdivisions of degrees into minutes and seconds are the same as those for hours into minutes and seconds. Now we have several ways that we can express fractional parts of a degree. This angle could be described as 6.5 degrees in fraction form, or 6.5 degrees in decimal form, or 6 degrees, 30 minutes and 0 seconds in degrees, minutes and seconds form. These three expressions are all equivalent. When solving problems in trigonometry, you might need to know how to convert between these formats. At the very least, you will need to understand all three forms and be able to enter them correctly in your calculator, including when using the trig ratio buttons sine, cos and tan. For example, a diagram might include an angle written as 14 degrees 18 minutes, which is equivalent to 14.3 degrees. Let's see how our calculator can help us. To make life easy, there is a button on your calculator known as the degrees, minutes, seconds button, but colloquially referred to by various names, such as the bubble button or raindrops button. We are now going to learn how to use this button, but for those who thrive on deeper understanding or enjoy mental calculations, I will cover non-calculator techniques in the Part C video of this subtopic. First of all, find this button on your calculator, or yours might have a DMS button, literally abbreviations for degrees, minutes and seconds. The symbols on this button represent the units we write for degrees, minutes and seconds. This statement is read as 5 degrees, 12 minutes, 30 seconds. We will begin by learning how to enter the values correctly. To enter this example, you simply type 5, tap the DMS button, then 12, tap it again, and finally type 30 and tap the DMS again. The first thing you might notice is that this calculator has reused the degree symbol for minutes and seconds. Just make sure you don't write it that way in your answers. Fortunately, it's rectified when you press equals, as you see here. So that is how you enter angles given to you in the form of degrees, minutes and seconds. Let's look at an example. If you need to calculate the sine ratio for 32 degrees 15 minutes, you simply tap sine, then type 32, DMS button, 15, DMS, close the parentheses, and pressing equals will give you the answer, which we then round appropriately or as directed. Pause the video if you'd like to try this calculation, which could be required when calculating an unknown side in a right triangle. Typing 15 times cos 50 degrees 48 minutes, then equals gives us this unrounded answer, which is 9.5 when rounded to 1 decimal place. As you can see, it's fairly straightforward to enter angles in this form. But how do we change an angle that's given in decimal or fraction form into degrees, minutes and seconds? Let's do some examples and then see how to use it when solving trig problems. The answer to this one is hopefully obvious, since half a degree must be half of 60 minutes, which is 30 minutes. So 10.5 degrees is the same as 10 degrees 30 minutes. But let's see how your calculator will convert it for you. I am demonstrating on this Casio calculator. Yours might respond differently or have different buttons, so be sure to refer to your user manual. We simply type 10.5 and tap the degrees minute second button, giving us 10.5 degrees on the screen. Now press equals. Simple. The 0 seconds on the end confirms that it is exactly 30 minutes with 0 seconds. I haven't written the 0 seconds because we usually only require answers correct to the nearest minute. However, if you wanted to show the greater accuracy in this instance, you would simply include the 0 seconds like this. There is another way to get the answer. This time, just type 10.5 and equals. Tapping the degrees minute second button changes it instantly to 10 degrees 30 minutes and 0 seconds. It's actually the same number of button presses this way, but notice that the top display doesn't have the degree symbol doing it this way. The benefit, however, is that when you get an answer for an angle, you can instantly change it into degrees, minutes and seconds without needing to retype it. More on this soon. First, you might like to pause the video and try this one on your own. Simply typing 54.16, tapping DMS, then equals, we see that it exactly equals 54 degrees, 9 minutes and 36 seconds. I already mentioned that we usually only require answers rounded to the nearest minute. Remember, minutes and seconds are base 60, not 10. So they are not decimals and thus are not rounded based on reaching 5 or higher. Half of 60 is 30, so we round up to the next minute once we reach 30 seconds or higher. Our answer is clearly more than 30 seconds, so rounding to the nearest minute would give us an answer of 54 degrees, 10 minutes, correct to the nearest minute. It's important to realise that you should not convert to degrees and minutes from a rounded decimal value. 54.16 degrees could have been rounded to 54.2 degrees. Converting this will give 54 degrees and 12 minutes. So you can see the impact of rounding. Always use unrounded values when converting to degrees and minutes, if possible. Let's conclude this lesson with a basic trigonometry problem. We are required to calculate the marked angle. Refer to video 4 in the series if you don't know how to do this. Labelling the sides and using SOHCAHTOA, we determine the tan ratio for the angle theta must equal 3/4, or 0.75. Even without understanding it, typing this expression will tell you the required angle. Remember that you could have used 0.75 or even 3 divided by 4, which might even be faster than using the fraction key. We could round this to a required number of decimal places if requested, such as 36.9 degrees, but pressing DMS will change our unrounded answer to degrees, minutes and seconds. This time, our answer has less than 30 seconds, so rounding to the nearest minute, we'll leave it as 36 degrees, 52 minutes. If you found this tutorial useful, please like and subscribe. Be sure to check out the rest of the videos in this series for more help with trigonometry in right triangles.